Hello and welcome to the Daily Space. For today, I think it's August 8th, but I could be wrong. It's that kind of a day already. In fact, I can actually look up the date. I had it wrong. It's the 8th. Hello and welcome to the Daily Space for today, August 8th, 2018. I am Dr. Pamela Gay, and I am going to make your chat bigger. Sorry about that. We're having some formatting issues at the moment. I will fix this more in a moment. So it's a slow news week as everyone holds their breath, waiting for a number of exciting things that sit on our horizon. In some cases, kind of literally. Currently, the Parker Solar Probe is waiting for launch, and as it waits, we wait with it, hoping that it will be able to launch on time. It is currently scheduled to have its earliest possible launch 2 days, 14 hours, 29 minutes, and 41 seconds from now. This is the earliest possible launch. It will be able to launch, and they've redone these calculations, so I have to look. It will be able to launch through August 23rd. They did calculations to figure out if they could extend out its launch window. This particular time of year, well, as anyone who's been looking at global radar realizes, our planet is kind of stormy. So it's always good to be able to pad your launch window with extra dates to make sure that weather and rogue fishermen and all of the things that, well, spacecraft aren't responsible for but can stop their launches don't have the possibility of stopping this mission. Now, the Parker Solar Probe, I have to admit, I had some bad information yesterday. I'm going to say this more than once today. Yesterday was apparently just a bad day. So yesterday when I talked about just how close it would get in, the corona of the sun, I gave the correct number. It's millions of degrees in temperature. But the region of the corona that's millions of degrees in temperature, Parker isn't going to quite get there. And what left me confused is while the corona can be 4 million degrees, Parker Solar Probe is getting as close as 4 million miles, and my brain confused those two numbers. So at its distance of 4 million miles, or roughly 6.5 million kilometers, Parker Solar Probe is going to experience temperatures of 2,500 degrees Fahrenheit, or roughly 1,400 degrees Celsius. This is almighty hot. This is still something quite challenging for our little spacecraft. And we can still say it's entering the sun's corona. It's just not entering the hottest part of the sun's corona. Now, in order to be able to withstand all of this heat, this little spacecraft that can is set up in a way, well, quite unlike anything else that we've ever deployed. This spacecraft, unlike most spacecraft, won't deploy its solar panels once and call it good. It's actually going to have to keep moving those solar panels in and out so that it can go from getting the maximum amount of area being hit by the sun that it needs to stay powered when its orbit carries it, well, more than 1 AU away from the sun. And then when it snuggles back in, when it starts to reach that distance of 4 million miles, it's going to have to pull in its solar probe, pull in its solar panels to reduce the amount of sunlight that's hitting them and to reduce the amount of heat that they're experiencing. So this is a probe that is going to have to constantly change its shape, which is kind of cool. The overall mission profile is one that has it going through its closest approach to the sun for about 11 days. So its orbit is going to snuggle in close to the sun, and then it zooms back out. So if my microphone is the sun, it's going to come in close for about 11 days, and then orbit back out to just past the Earth's distance for its largest orbits, and it will actually also be changing its orbital size over time, such that in the end, it will end up just, well, about 9.5 solar radiuses away from the sun. So this is from from the center of the sun to the surface. Take that number, multiply it by 9. You're still in the sun's corona, and that's how close it's going to get on its closest approaches. Now, quite often it's going to be more like 35, 30, 20 something solar radiuses away. And as it shifts its orbit, its furthest point is going to be at its furthest about 1.02 distances of the Earth to the sun, and then it will reduce it down to closer to 0.7 times the Earth's distance from the sun, or 70% our distance from the sun. Now, with all of these different complexities, they also had to build on, what they call a RAM. This is a spacecraft that has one side that is designed to basically shadow the rest of the spacecraft from the sun's radiation and light, essentially casting a small shadow to protect the telescope, the space probe, from direct solar, experience. Think of it as that coronagraph that we put on telescopes to block the main disk of the sun. It will still be able to observe the corona all around it. So we are now 2 days, 14 hours, 24 minutes, and 16 seconds from launch. And we're going to do everything that we can to bring that launch to you live here on CosmoQuest. More details about that are to come, and I promise you there will be coffee involved. So moving on to other things. Yes, we will probably have a little bit more on the sun and TESS every day this week. Not TESS, Parker Solar Probe. I say TESS because TESS is our next big story. Here is the tweet that showed us, an amazing discovery, not because it was scientifically cool, but because it showed us, at least TESS is returning data. This is our first hint of what we are likely to see from the terrestrial, I need to look in order to get the name of this spacecraft correct, the Transiting Exoplanet Survey Satellite, which, thank you so much for the subscription, Graham. Thank you. Can we light up the chat with rockets to celebrate, please? So the Transiting Exoplanet Survey Satellite, which is named TESS, thankfully, it is in the process of coming up to speed doing science. But in earlier phases of the spacecraft, while they checked out their technology, they just happened to catch a comet. Now, the goal of this mission is to observe the faint brightening and dimming of all the nearest stars to look for the nearest planets to Earth that happen to be alien worlds in other star systems. This is a pretty cool mission. Kepler, it's focused on one particular square on the sky. And so it's finding planets at a whole variety of different distances. And because some of the worlds that it's finding are quite far away, we can't do all the science that we can do because there's just not enough light. With the things that TESS is finding, because they are closer, we should be able to do a lot more different kinds of science with what we're able to find. Now, the trick is we have to get the data we need, and that means lots of calibrations. While doing those calibrations, this little spacecraft was able to, turn up a comet and a whole bunch of asteroids, and you can see those in this video. The way that this rather ugly image was produced is they took a time series of different images, and all of these images were stacked together to get the average of what this piece of the sky looks like. So if you average the brightness of stars that vary over many different nights, you'll get, that star's average brightness. If you average the sky background, you'll get an average background that may be interrupted by moving asteroids. And by subtracting that average taken over time from each of the individual images that went up to building that average, what you're able to see is how each image is either, for those particular pixels, brighter or darker than that average. Now, to get particular, looking at this image, we have this one thing right here that appears to me to be a variable star because it's there for quite some time and doesn't appear to be moving. It could also be an asteroid, but the movement doesn't seem to match that. We have another one over here that is exhibiting very similar behavior. My initial thought was that this was one asteroid that had jumped between these two locations, but the motion doesn't seem to make sense because you don't have all the things in between. You do see other objects that move through the image. So there's a little spud that moves over here that you can see. And the more I look at this, the more I see things that come and go. And depending on how they come and go in the image, this is how we figure out, is this a variable star that's getting brighter and fainter and gets subtracted to black when it's fainter than the average and shows up as white when it's brighter than the average? Or is this a meteor that is simply skipping through the frame, appearing only sometimes? So there's a lot of science in this little image, and this gives us a hint of what is to come in the future. Now, continuing on to one more reminder for those of you who weren't here yesterday. This weekend is just full of various opportunities to, well, get some science. Instead of having to go watch a spacecraft launch and wait for it to get snuggled up next to the sun and send us back new information, you can, in fact, go out that same night that, well, if you're in my time zone, you're staying up late to watch the Parker Solar Probe. You can go outside and watch the Perseid meteor shower. There is a small but non-zero chance that if the bugs are not too annoying and if the Wi-Fi is with me, I will be outside with I will be outside with my laptop with a hammock, bringing you my coverage of the Perseid meteor shower. I need to figure out how best to share that with you, while also waiting for the Parker Solar Probe to launch. This will be a complete experiment. Lord only knows if any of this will work. And as always, there's the case that other needs may arrive that need attended to. But this is currently my crazy plan, inspired by you asking, can we somehow stream the Perseid meteor shower? And as I thought about it, the answer became, well, maybe. So we'll see what we can do. So that's the news for today. Following this episode of The Daily Space, I'm going to turn this channel over to Dr. Matt Richardson, coming to us. Actually, he's not coming to us today. I'm going to be turning this channel over to Joe Myers, who's going to be, well, I'm not sure what he's going to be doing, but he is going to be taking over this channel. Normally, on Wednesdays and Fridays following The Daily Space, we offer you Astro 101, taught by Dr. Matt Richardson, who is at the Planetary Science Institute, who is teaching our programmer, Joe Myers, all the science he needs to understand the software, or understand how the software he's expert at writing is going to be applied to doing science. We also bring you various other programs throughout the week, so go ahead and follow so that you can find out whenever we go live. You can count on seeing someone here at 1 p.m. every Sunday for Astro Office Hours. Most Sundays it'll be Annie Wilson bringing us, well, information on exactly how all those amazing graphics you see in planetarium shows get created. Tuesday nights, I am here when, well, the software allows, to bring you Astro Office Hours and to talk about just how the world Kelt 9b is getting destroyed as it orbits Kelt 9. So check it all out. As always, we are sustained by you. Every subscription helps and every bit really matters. So if you've got any questions, I'm here to try and answer them. I just need to figure out which window I hid the chat behind. Here we go. There it is. So I'm going to scroll back and look for anything that may have been brought up. Hello, Rose and Michael. I'm glad you were able to catch things today. I'm sorry you showed up just as we were ending things last night. And as Big J, who's also Joe Myers, is saying in the chat, he's going to be working on our transient tracker software for doing astrometry of stars. Okay. So Big J, I don't have any reclining chairs. I just have a hammock I need to figure out how to hang, given we only have one tree. And you don't want to be under a tree to observe Perseids. So Larry, what are you asking about in terms of the camera artifact? I suspect that you're talking about our test images. If you're talking about the ray that appears right here, it'll come here in a moment. Let's watch. Right there. That was actually Mars passing nearby this field, and an internal reflection inside the telescope as the, reflection of Mars light coming in at a funky angle reflected off the side of the inside of the telescope and cast a, not a shadow, but a beam of light across the detector. Repairman, I'm reading your question. So Repairman, I'm an observational astronomer, and if your work is theoretical in nature, I am not the person you want to have look at it. And I'm a programmer. I write software to facilitate doing astronomy research with big data, and I attract clouds, but am extremely good at operating telescopes in those rare moments when there aren't clouds. Yes, this is the difference layer composite fenring, only we use much fancier algorithms that reject things like, I don't know, cosmic rays and other craziness that happens with detectors. So insane noise in front of the telescope. So that's actually just an artifact of how the subtractions are done. If you have an average that has a star that is brighter than the comet, when you subtract that star that is brighter than the comet out of the comet, it creates a dark spot on top of the comet. So this is just a funky way the noise or the background objects manage to somehow appear in front of the comet. This is something I probably need to write a blog post about to try and explain to people, because a lot of folks are getting confused by this image. Okay. Hello, Carolyn. So that's really cool about the meteor that you saw the other night. It's true that we don't just see Perseids on the night where they're peak. What happens is the comet whose orbit we're passing through, it doesn't always go the exact same place year to year. So if you think about it, there is, I have the perfect example here. If I can figure out how to untangle everything on my desk. I have a pile of cables because I'm just that kind of a human. And what you can do is you can think of the comet's orbit as a series of imperfect ellipses that change slightly from year to year. Let me figure out how to hold this so you can see it better. I need like a dark background. Okay, we're going to pretend, and I'm just going to hold it close. So we have a whole set of ellipses that vary from year to year, and at the front of it is the comet's present position. So what we're looking at is a track of all the different orbits over time that our USB comet has gone on. And because each orbit is just a little bit different, as there's different solar interactions, as there's different interactions with the outer planets, you end up leaving behind dust in a lot of different places. Now, the most recently formed part of that set of overlapping orbits, in this case, the place that Comet Swift-Tuttle appeared in 1992, it's going to have the thickest amount of debris. But all those prior passages, there's still junk left in those places that our Earth hasn't eaten up yet. And so we might pass through those earlier trails a little bit earlier, those later trails a little bit later. And as the Earth passes through this cloud of leftover cometary debris, we go through fewer, more, oh my God, less, nothing. And so there's no night that's a wrong night to go out between now and about August 14th, but it will be the most exciting the night of August 11th to 12th. So I'm going to look and see what other questions. Fenring, I bring clouds. I don't necessarily bring rain. Looking to see what other questions. Okay, so APOD has an amazing animation of this. Can you drop in a link, Larry? That would be easier than me Googling while trying to talk. So what other questions do you folks have? And it's going to be a busy week, and then it's only going to get busier. Next Wednesday, I will be boarding a set of flights to fly away to attend the International Astronomical Union meeting in Vienna, Austria. I'm going to be there both as an officer of the society. I promise I am not responsible for Pluto's fate. I was not yet a member in 2006. Here we go. Here is the... Oh, I didn't quite get it in correctly. Sorry, trying, failing. Oh, these are two different users. Okay. So there we go. This is so here's where the asteroid shower will be on the sky, and here's the out of the solar system view of what's going on. Now, as I was saying, next week I'll be boarding a plane, flying away to the International Astronomical Union. In addition to being Secretary of Division C, I am also going to be Editor-in-Chief of the IAU's daily newspaper, which will be coming out strictly in an e-edition, open to the world. I will be working to continue bringing the daily space to you while I can from the IAU. So you'll be getting all that's new, fresh from another continent. While I'm traveling, and in fact also tomorrow when I'm catching up on some research, we'll have Dr. Andreas Plazis here bringing you the daily space. This show comes to you every Monday through Friday at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time, or if you're at the IAU, 7 p.m. So please keep joining us. Tomorrow, directly following the Daily Space, I will be taking the channel over from Andreas and bringing you a special guest on the day on Learning Space. Our guest this week for Learning Space is going to be, I'm sorry, I have to look. It's going to be Emily Carney, who does Hipster Space. I'm sure this is going to be a fun show, and we're going to be talking about more ways that people find to mix science and communication and get a little bit of personality into the science. So thank you all for joining me. If I don't see any more questions, I'm going to go over and, well, let Joe show you exactly how things transit in our universe. But yeah, I think this is like not an image, it's a JavaScript or something. So go ahead, explore that APOD mission. Get in some, solar system exploration from your keyboard. And don't forget, go outside, look up. Mars is bright, Saturn is bright. Perseids are starting. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember, like I said, go out and look up. Bye-bye.